Okay, so here's an example of a problem with proportionality. It says here, power P of a gear varies directly. There's my key part. With the radius R of a gear, find the constant proportionality if P equals 300 when R equals 50. Again, so we got, I'm just going to write it down in the order that it says. So P varies directly with the radius. So it's constant proportionality times the radius. Our job is to figure out what the K is. We've already been given some information. Let's fill it in. And we're basically just going to fill in the info it gives us and figure out what the K has to be. So we already know that if P is 300, that the radius is 50. So all we got to do here is solve for K. To do that, it's all right. We got to get this K by itself. So you get the K by itself, to get rid of this 50, you do the opposite of multiplying, divide both sides by 50. Okay. The 50s cancel out, leaving just that K. On the left-hand side, you figure out what's 300 divided by 50, and you get 6. Yay, we figured out our constant of proportionality. All right, so now we can put that into our regular equation. We now know that P is 6 times the radius. All right, so the power of the gear is always going to be 6 times whatever the radius is. Very straightforward. If it varies directly, it's going to look like this. You just have to use the information given to figure out what K is. Sometimes problems can look scary. This one doesn't even fit on your screen. It says the number of hours, H, it takes for a block of ice to melt varies inversely. And then it says as the temperature. It varies inversely as the temp. If it takes 2 hours for a square inch of ice to melt at 65 degrees, find the constant of proportionality. All right, so we know that it varies inversely. So know that the number of hours varies inversely with the temperature. So when it varies inversely, it means it's dividing. So what we do is we fill in stuff that you know, and you go from there. So you know it took 2 hours. You know it took 2 hours for some constant proportionality divided by the temperature, which is 65. Now to solve for K, we're going to get rid of that 65. So we're going to multiply by 65 on both sides. When that happens, 65 cancels the other 65. We're left with K. On the left-hand side, you got 165 or 65 times 2, which makes 130. Yay, we figured out our constant of proportionality. So again, all that info tells us is our equation is that H equals 130 divided by the temperature. So whatever the hours it is going to be 130 divided by the temperature. The temperature is 130, it'll take an hour to melt. Temperature is 65, it takes 2 hours to melt. If the temperature was 13, it would take 10 hours to melt. All right, we have our basic equation. You fill in what you know, you get what K is, and then you can write your equation. As we're doing these, I am just as surprised by you. I don't know what these are. We have a formula. Z varies inversely. It gives away what we're going to do. So it's going to be Z inversely varies with P. And then, of course, it'll give us some extra information. If z is 200 when p is 4, okay, let's fill those in. 200 when p is 4. This one asks us to find z when p is 10. So let's figure out, we got to figure out what k is first, and then we'll figure out what z. So, all right, so let's multiply by 4 to solve for k. Right, 4 cancels a 4, so we're left with k. 4 times 200 is 800. So k has to be 800. So our equation is z equals 800 divided by p. All right, and then here's our actual question. It says find z when p is 10. So z is going to be 800 divided by, well, p is 10. Let's make p 10. What do you get? 800 divided by 10 is 80. And there we have our answer. Z's got to be 80 when p is 10. All right, and one more to do. Remember, if you get left behind, just pause it. All right, so this one, still cut off your screen. Variable m varies directly as variable t and inversely as variable, you can't see it, variable s. All right, so this one's got double thing. Variable m varies directly as variable t and inversely as variable s. So the inverse part is that. We don't need a separate k because this k takes care of the t and the s. If they were separate, you would be able to mush them together into one k anyway, so it doesn't matter. And then, of course, it gives you some starting conditions to figure out what it has to be. So we can go crazy. You can add all sorts of, there can be more than one thing. It will tell you, though, explicitly each one. So varying directly as t means it's getting multiplied by the k, and inversely means it's dividing the k. All right, let's substitute in. You get 24 equals, there's a k times whatever t is divided by what s is. All right, let's start breaking this fraction down here. It's being divided by, oh, we forgot to put 2. It's being divided by 2, so we're going to multiply by 2 on each side to cancel that out. I get 48 equals k times 3. And then here, to get rid of the 3, right, we divide by 3. (48) divided by 3 is 16. So we get what our k is. So our original thing up here, we have m is 16 times t divided by s. And it asks us to find m when t is 5 and s is 8. So m will be 16 times 5 divided by 8. Yay. Here I'm going to simplify. 16 over 8 is 2, so it's really 2 times 5, which is 10. So the m has to be 10. So we can do simple ones to complex ones. It's all just multiplying or dividing.